Quick, let's run under that tree.
I don't think a tree's the best place to be during a lightning storm. But I found a cave up here. Follow me.
Oh, my brother tried to kill us.
Lightning usually strikes the tallest thing in an area. Isn't that right, Xenon?
Zink, that's correct. Lightning may seem like just an electric charge, but the chemistry within the cloud is quite fascinating. Clouds form when water vapor in the air condenses around dust or other particulates. These grow into storm clouds when increased temperature moves ice and water inside the cloud around. As that happens, those particles become charged.
Yeah, I think one of my science teachers talked about this. The positive charges separate and move up as the negative charges move down, right?
Zink, you must have been an excellent student.
Are you saying me and Yuri are stupid because we never paid attention to our science teachers?
Ruth, where did you come up with that? Anyhow, as Zink likely knows, storm clouds generally grow in midday as the air warms and the cloud grows taller. Of course, other weather-affecting factors are at play, such as latitude.
Attitude?
I believe you misheard me, Yori. Latitude refers to how close we are to the planet's poles. Planets are cooler at the poles, warmer near the equator, where they receive more warmth from their star, such as the sun.
I recall my teacher saying that there's updrafts and downdrafts in the cloud. Downdrafts transport hail and ice from the colder upper regions of the cloud to the lower regions and...
Yes, upper altitudes have less dense air, fewer molecule collisions, and are thus generally colder than lower elevations within a cloud. And I believe...
Ooh, there's some hail now. Yum, it tastes like ice cream, except with no flavor.
Oh, golly gee, Yuri. Incredibly delicious. I so can't wait to try some.
Say, Zink and Xenon, what do you mean by charged particles?
It has to do with electrons, right, Xenon?
Yes, all atoms, including the four of us, have electrons orbiting their nuclei. When atoms bond to form molecules, sometimes those molecules are polarized. This includes the water molecule, made from two hydrogen atoms covalently bonded to an oxygen atom.
Oh, yeah, I remember now. Although water's equal number of protons and electrons make it a neutral atom, there's a slight negative charge on the oxygen side as it pulls negatively charged electrons closer to it, and a slight positive charge on the hydrogen atoms.
Quit showing off your attention span, Zink.
Ruth, I'm guessing you spent too much time on your cell phone during science class.
Her teachers were always confiscating it.
Tattletale.
Oh, wow, it's snowing. We can eat flavorless snow cones now.
I think that's actually grapple.
Zink, you appear to be correct once again. Hail formation is an exothermic process that releases heat as the water freezes, and some of that heat will warm other hail particles, which turn to soft hail or grapple.
Yeah, and I recall that snow doesn't typically form in thunderclouds as colder air is needed to condense water vapor to snowy ice crystals without that in-between stage of liquid water.
Zink, you must have been a science teacher's dream student.
Quit flirting with my boyfriend, Xenon.
I'm not flirting. And why don't you put that cell phone away and learn something for once?
I love lightning. It's so beautiful. But why so noisy? And how come we don't see it and hear it at the same time?
Lightning may be beautiful, but it's dangerous. And with the exception of xenon, we're all metallic elements. Lightning is at least 20,000 degrees Celsius, hot enough to melt us to liquid metallic mush.
Yori, as we said previously, there are charged water particles in the thundercloud. Eventually, the charge difference between the cloud and the ground becomes overwhelming. This results in a rapid discharge of electricity, in this case, lightning, created by electron movement in the cloud. Because lightning is so hot, it heats and expands the air rapidly as it descends, creating a sound wave we call thunder.
Sound waves travel more slowly than light waves, which, as I understand it, is why we see lightning before we hear it.
I believe that's true, Zink. And of course, we've observed that lightning hits the tallest things around us.
Xenon, isn't that because the negatively charged lightning electrons are attracted to the first positively charged item they encounter on the ground?
Oh, Zink! I imagine you kept your cell phone in your backpack during science class. Yes, a positively charged tall object sends an invisible streamer that attracts lightning's path to the ground.
I can barely remember to keep my cell phone charged. But everyone's mind wanders once in a while, and in my case, that means I'd get in trouble with my teacher for playing my air saxophone.
Ugh, that's just weird. And Xenon, why is your portable weather station getting all wacky?
Does it have something to do with all that extra wind and flavorless ice cream?
When areas of high-pressure gases move into low-pressure air, it creates wind, but, we have some rather radical fluctuations in air pressure at the moment. I think we may be beneath a rotating supercell storm.
Is that what I think it is?
It's a wind-shaped snow cone!
No, dummy. That's a tornado. Oh, we're doomed.
I was exploring this cave earlier. Follow me.
Wow! Did any of you who paid attention in science class learn about snow cone wind?
You mean tornadoes?
It occurs when a warm surface wind blowing from one direction meets a cooler wind blowing in a different direction from above.
And that leads to a rotation of winds in the thunderstorm updraft, correct?
Yes, which can lead to a funnel cloud.
You mean snow cone cloud.
We dodged that bullet.
But my weather station didn't.
And the mountain below us went bye-bye.
There's been a landslide. There's no way off the mountain now.
Aren't you supposed to say we're doomed?
Yeah, I guess we are, 'cause I don't have any cell phone bars.
The storm probably knocked out the cell towers.
Is that what I think it is?
Over here, we're stranded.
Bonjour. Hop on board, dudes.
Oh, you saved us.
We're all quite happy you're here.
When we saw you climbing the mountain before the big storm, we presumed you might require some assistance.
Let me play you all a thank you tune.